Hello, everyone. I'm Paul Musto, and welcome back to another episode of Siemens Startups, a podcast series where we speak with entrepreneurs to gain insight on how they turn their innovative dreams into successful companies. Today, we are speaking to an interesting company that is a little bit outside our normal typical industries. Patrick Ropel and Nicholas Prue-Jones are joining us today from Evoke Buildings, a Canadian company that collaborates with their partners to consult and create extremely innovative building designs that are highly energy efficient. Patrick is one of Evoke's principals and building science specialist, and Nicholas is one of Evoke's newest building science engineers. Hi, Patrick and Nicholas. Very nice to speak with both of you today, and I very much appreciate you taking the time to be here. As I briefly mentioned, Evoke is a bit outside our typical type of company we speak with, which I think it makes it a bit exciting for our audience who have maybe listened to our other podcasts. And so hopefully that we'll make this a very interesting episode for people to listen to. But before we jump into things, why don't I kind of hand it over to the two of you and give us a quick introduction of yourselves?
Thank you for that introduction, Paul. I'm one of the founders and owners at Evoke. I've been a building science specialist for the past 18 years in Vancouver. Currently focused on developing industry tools and guidance related to energy efficiency and reducing greenhouse gas emissions in buildings.
Excellent. Nicholas?
Hi. Yeah, like you mentioned, I'm Nicholas, and I'm one of the new hires here at Evoke. My background is originally in electrical engineering, and then I made the switch over to building science just about 2 years ago, and just have a little bit of experience in the field. And so far, it's been really great.
Thank you both for joining. And so honestly, again, since this is kind of a new industry for me, the term building science is not something that I'm familiar with. And from the little bit of research I've done, it almost seems like it's maybe a bit unique, or maybe it's a different type of characterization in Canada. Maybe just give everybody a sense of what a building scientist is.
So, building science specialists, not necessarily unique to Canada. Canada has taken a more focused approach to building science in the past, given the challenges of building comfortable buildings with comfortable indoor spaces that are subject to extreme weather, and a desire to have energy efficient buildings. So some of the science that we use today kind of started back in the 1970s when they had the oil embargo, where you wanted to have increased energy efficiency and also durable buildings. So the science part to it is kind of a nod to the science part and the analytical part. Other titles that you might hear in industry are building envelope consultant or building enclosure specialist. They could be an architectural firm, they could be an engineering firm. But the science part was always traditionally done in research institutes. So in Canada, it was the National Research Council. In the States, it was Oak Ridge National Laboratory or Lawrence Berkeley National Laboratory. In those kind of national laboratories, and now some of that research and development's done in private industry, and we're kind of one of the firms that kind of take that science and apply it to practical solutions for buildings.
So this is really a building science, as you describe it, is not really related specifically to the construction of the building or the design of the building. Why don't you give us a little bit of an explanation of kind of where the focus tends to be?
Couple people in our firm who involved with the construction of buildings, where they're looking specifically at the building envelope. Nicholas and I, our specialty is looking at the performance of the building envelope. So we're really focused on kind of the heat, air, moisture flow through the building envelope itself, looking at components or systems, like how wall and roof systems interact with the building itself is our specialty. But building science can also touch upon other disciplines like structural, acoustics, fire protection, and whatnot. It looks at the science behind how buildings kind of operate.
The position itself as a building science specialist, I would imagine it's just a different type of curriculum or a more rigorous curriculum. What does it actually take to be designated as a building science specialist?
That's kind of evolving now. So it's becoming more of a formalized process, and Nicholas kind of went through that through some of his education. When I went through building science, I did a master's in building science and went to a University of Waterloo that was specialized in that subject area. When I graduated, I was one of the few that had a master's specialized in building science. We were looking at more analytical tools for the industry. I was one of the few people that had that expertise, and everything just kind of followed from that, where things are becoming more formalized, with more designations and stuff.
By its very nature, building science is an interdisciplinary field, right? You need to know a little bit about buildings, a little bit about modeling, a little bit about a ton of different things. And like Patrick mentioned, we're focused on one specific area of building science, but you could be specialized in acoustics or different side of things as well. So in the past, lots of people have come from lots of different backgrounds, especially civil engineering, and they do a master's and then they kind of focus in on building science. Whereas now there are more specific building science programs being created because there's a need for this position, especially where we're located in Vancouver. You have so much rain and wind-driven rain, and the buildings get so wet that it ends up leading to a lot of big issues down the road. If you've heard of the leaky condo crisis in our area, essentially, that's a big driver for our whole industry, is just the fact that so many buildings have been built poorly in the past and have deteriorated much faster than we'd expect. So that's where we come in and we try to make high-performing buildings, but that are also very durable.
Logically, I was thinking about it, and as I was doing the research, when they put up a building, and as you call it, the envelope, when they're designing the exterior and constructing the building, it makes sense that there would be a lot of science involved in the structural integrity and the acoustics and the thermal pieces, and kind of doing a little bit more research into it. I mean, there's, every element of how the building is put together could cause some airflow leakage or thermal leakage. So it was just impressive to see how much science was actually involved in putting all that together, right?
And that's one of the big things in the past was we used to build buildings based on experience, is we knew what worked, what those are the buildings that kind of stood up, and let's keep building it that way. And when things like the leaky condo crisis happened, it was when things were cut back to the point that there was kind of issues. So that kind of put the need for some more professional review of certain types of buildings. But now what's happening with climate change and wanting to address embodied carbon, so like how much carbon is kind of stored in a building, and that there's a real drive for more data and analytics of making sure that we're looking at things like thermal bridging, which is it's like additional heat flow that goes through the envelope because there's like a conductive element like a piece of steel or concrete that's bypassing the insulation and whatnot.
Yeah, and actually, believe it or not, that was actually a fairly interesting site as well. There was another term I came across on your website called building envelope thermal bridging. Maybe you can tell a little bit about that and what that really means.
So like when I first started consulting, this thermal bridging, this additional heat flow that kind of goes through highly conductive components, was largely ignored by industry. One of the issues is some people didn't think it was a big impact, that they kind of didn't need to account for it, but also just the complexity and amount of details of construction. If you look at wood, steel, concrete construction, there's a lot of variety there. It was just too much for people to account for it, kind of using the knowledge at the time. So at a previous firm, we got a research project from ASHRAE, which looked specifically at the impact of thermal bridging. And it just started at looking at 40 details that represented construction practice across all North America. That kind of work showed how much the impact thermal bridging had on the heat loss or the additional energy that's needed to kind of keep buildings either hot or cool. That work showed that the impact of thermal bridging could be 60 or more % of the heat flow that was attributed to these details was being ignored. And then that led to other projects to try to quantify more and more details, where it came to like we were doing like in a PDF kind of guide. It was becoming such a big kind of document with all the details that it's solely being transformed into a web application where it helps people do the calculations in practice, helps people find details, and it's being implemented in codes somewhat in the United States, but it's heavily referenced now in Canada as we're trying to introduce new codes to address climate change.
I would just add, as we're becoming more and more focused on having extremely high-performing and well-insulated buildings, the more this starts to matter. This has always mattered, but it mattered less in the past when we were building generally pretty average buildings, which now we would consider poor-performing buildings. And as we're adding tons and tons of more insulation, okay, you have a great building, and all of a sudden these few elements just defeat the entire purpose of putting on this extra insulation and all the other good details that we're doing. So got to address it.
And that has two impacts with cost and how like thick walls are, and that has other implications in our industry. But also now that we're looking at the amount of carbon used to create materials, if you're putting a bunch of insulation on your building and it's not effective, that kind of defeats the purpose of all the energy efficiency gains you had in buildings and that. So it's looking at that balance of, are you using your materials efficiently, and is it actually reducing the overall greenhouse gas emissions rather than just focus solely on energy efficiency?
I was kind of watching a couple of the videos on the site that has the BETB guide. They call it the Building Envelope Thermal Bridging Guide. And I mean, the modeling gets down to very fine details, right? Even brackets and structures that hold things together. I think as a typical person, you'd say, okay, well, where a building meets a foundation, there could be, some leakage there, right? In that joint or other joints or other connections in the house. But this gets really down to the finest details, I think, at least from what I read.
To that point, like that was some of the innovation that happened over the years, is how do you present information to people that it's not too complex and overwhelming? So like some of that work was to make things generic and present it in a way that they can compare to like apples to different solutions and arrive at the right kind of decision without having to get overwhelmed by it, like say, oh man, there's just thousands of details here. I don't know where to start, kind of thing.
How do you quantify the benefit? Is it quantifiable in terms of how much energy you're saving?
Yeah. Another partner at Evoke, she's focused on whole building energy analysis. So that's another part of our business. So the data from the Building Envelope Thermal Bridging Guides used in energy models, where they look at the impact of basically what's the amount of thermal resistance that a wall or roof will have in conjunction to all the mechanical systems and electrical and all that stuff. So then you look at these energy models, will look at both energy consumption for either a specific project, or you can look at kind of archetype buildings that say like an apartment building usually has these kind of characteristics. This is the amount of energies that you're saving because of these specific measures.
I saw on the website somewhere, the estimated energy saving somewhere around 50% on some of the building redesigns even, right? Just taking an existing structure, running the simulations and updating the thermal efficiency of it, right?
Yeah, and that's like, so a lot of that stuff was done in new construction. We're in Canada, we're starting to focus on existing buildings. Also in the States, like New York is putting in similar policies in that as well. But some of the projects that we're doing in pilot studies, they're calling them deep energy retrofits, where you want to have like some of the targets are 80% savings in greenhouse gases compared to the existing buildings. So it's not just the envelope stuff that we're talking about. There's other mechanical upgrades and whatnot as well, and electrifying buildings and whatnot. But there's all this data that we're providing kind of feeds into kind of bigger models to help people make decisions.
Is this pushing into driving all new kinds of building regulations or requirements?
We've been involved in some of the policy work in both Canada and the US. It is changing the way that we look at buildings and analyze them. In the past, it used to be from energy efficiency is like the first approach that you just look at it prescriptively, is saying just put this amount of insulation, this type of window, do this, and you can comply to code. Problem with that is that kind of prescriptive approach doesn't do well when you're trying to tackle thermal bridging that kind of happens in between components. So it doesn't quantify that difference, and it would be largely overlooked by prescriptive codes. And that's kind of leads into performance-based codes, where you're looking at the energy of the whole building. And some of the past regulations were just looking at comparing, well, this is a baseline building, and we're comparing it to what you were designing kind of thing, and looking at how much better it is. That also leads into some inconsistent outcomes. So what's happening in a lot of these codes, they're going to absolute targets, and they're looking at the energy use, but also other things like greenhouse gases as targets for the building that you have to meet. So it's driving a lot of change in industry right now.
Well, we kind of switch gears. Well, tell us a little bit about Evoke Buildings and kind of what your charter mission is all about.
So Evoke started a little over a year ago. 3 of us started the company to respond to changes we saw happening within the building industry. We saw all these changes happening. We were at kind of a 1,000-person firm, and seeing that to kind of change how you're doing things on a larger firm was difficult. So we decided to start a firm and build it from the bottom up. And one of the things is the building industry is kind of slower to adopt new technology and change compared to other industries, probably like a lot of the ones that you had on your podcast in the past. But that change is happening, and the kind of shift in response to climate change and greenhouse gas emissions related to buildings, it seems to be accelerating things more than what we've seen in the past. So things are changing, and because of those codes I talked about, is people don't necessarily know how to meet the regulations. So they're really crave for a lot of information and guidance how to meet these new regulations and how they're going to respond to it in a competitive way. So kind of what we saw in the past, our industry relied mostly on experience, but it's becoming increasingly important that we evaluate new systems in a kind of timely manner through a design process on a building, and give kind of feedback to kind of design that the end regulation, or you meet the certain targets that you have to do on the project, but not necessarily constraining yourself too much early on in design, that you're able to have some, like, you also have to look at things like costs, there's fire protection, and there's a lot of things to look at, that you provide data to industry, that it's more driven on big data that you would see in other industry. It's kind of creeping into our industry as well. Yeah, we just saw a need to develop a company from the bottom up that was focused on people first, and better able to adapt to the speed of change that we're seeing.
I just would have to believe that, I mean, most architectural construction firms wouldn't have the expertise or skill sets that a company like yours would have in order to, meet some of these new demands that are out there, right?
Yeah, it's one of those things. Is like the Siemens software is not cheap for our industry. Like there's other stuff that people have used that was free, but it wouldn't be able to model all that complexity of the details that you've seen. And we've worked a lot with not only architects and development teams, but also manufacturers about analyzing their systems. So some people would want to buy the software as well. But it's one of those things is that it is an area, it's a specialty, or to be really good at it and produce like reliable and consistent results, you do have to specialize it, and it's not for everybody. Basically, is like someone can be in each architectural firm, that there might be a person to be there, but yeah. Nicholas can probably speak to that. Is the mentorship and teaching how to do that stuff's really important, and then procedures and whatnot. So it's one of the goals of kind of Evoke, and it's good having Nicholas here is kind of talk about like that, training the next group of people that are going to specialize in.
For sure. I would also add the work that Patrick has started in all of this. It's good for the whole industry, right? We can be doing specific work on a certain project or whatnot, but across the board, all these details and all the details that everyone is creating and working on benefits all building scientists, but also just the entire construction industry across the board to do kind of our part to get to these bigger climate change goals and trying to reduce greenhouse gas emissions. Like all of this work all ties in together. So at the end of the day, I think a big problem that engineers tend to have is we focus so much on getting the data and all that and not on the dissemination. And that's what this website, the Thermal Bridging Guide, allows. And that's why it's so important.
To that note is like a lot of people are like, why do you share all this data? Shouldn't you keep that in-house? But what I've always believed is there's no sense keeping all that data that no one knows about for that it might come up on another project. I find it wasteful to have that information and then having to do the same analysis on every single project, and it's not readily available. Is like when you make all this stuff available for everyone starts talking from the same playbook, and it just helps projects move along smoother and stuff like that.
Excellent. One of the things I always like to do when speak to a new company is I like to read the mission statements. I always find them completely fascinating. And fundamentally, I really believe mission statements drive kind of the cultural embodiment of the company itself. So, I mean, if I have it right, it's technically driven, people focused. We excel at what we do because we are knowledgeable in a spectrum of building related fields. We collaborate with the team to provide solution driven advice. We foster trust by being open, transparent, and candid. We work hard to change the industry for the better and to be innovative. One of your founding partners also had an inspirational statement regarding one of the projects. It is not the size of but the complexity of a project and the willingness of the team to work together that creates the most memorable projects. And throughout the website, I see a pretty common theme around collaboration and teamwork and team spirit and stuff like that. So, can you talk about how that influences your company?
Sure. Yeah, and I think that was a big reason for starting the firm. Like I talked about, that we wanted to be agile and responsive to industry, basically. So it's about creating this team that kind of has this growth mindset, that you're focused on your team Evoke, but also when you're working on projects with your clients, they're part of your team as well. So it kind of crosses over to kind of everything we do. It's like we don't just chase projects, but we work with certain individual and teams on all sides of projects or whatever they need us there for, and kind of just having that back and forth. One of the things that has been, didn't really realize it when we were starting the firm, but it's been a nice thing, is being a smaller company, is all these people that didn't necessarily want to work with us in the past as partners kind of thing are all like seeking us out, like saying basically, I've always kind of admired your work and wanted to work with you, but we were competitors in the past, where if we don't have that capacity in Evoke, we can team up with these other people that we like working with. So it comes down to just like working with people that you like working with, and you're going towards a kind of common goal.
Yeah, I mean, oftentimes it's obviously strength in the team, but kind of that willingness and the collaborative kind of environment that you create that creates that success, right? You all have a passion about a common goal. And just from the few words that Nicholas said, that it sounds like he shares that vision and that passion as well. So we'll shift the focus to you, Nicholas. So as one of the newest engineers at Evoke, what drew you to the company, and what drew you to a smaller company?
It was a really well-written mission statement. No, in all honesty, it is the people, though. I mean, of course, when you're starting off, your main goal is you just want to soak up all this knowledge and learn the most from some of the top people in your industry. And to me, that's what Evoke is. Like Patrick and Sophie are huge mentors. They've been mentors for tons of other new building scientists as well. And that's why I joined at the end of the day, right? Learn from the best.
And looking at your background, and I had asked because I'm an electrical engineer by education, you mentioned three things. So building science and construction, those things tie together, but then you have also a degree in electrical engineering. So does that play into this as well?
Yeah, it's not like if I was trying to recommend to someone what the ideal career path to become a building scientist is, would I say start with electrical engineering? But, of course, anytime you're in a multidisciplinary field, you can draw off of your past experience somehow. So a great example is building modeling and all of this NX work. I had a little bit of that when I was in university working on a design team. And we were actually using NX software to design these Bahas for University Baja design competitions. So, of course, that's direct knowledge that's now helping me at my current job, although it's been a while. But I wouldn't say that electrical engineering is the perfect background for this, but you can always find ways to tie in interesting background into a new field. So
I took a leap and I said, well, there's lots of electrical elements that are, in the building, although people always get confused with electrical engineering and electrician or electrical systems. But, I figured that might come in handy in this kind of simulation as well, right?
Yeah, I mean, we're less focused on the electrical systems of a building, but there are data acquisition and kind of analysis overlaps between what an electrical engineer may want to do and what type of field research you may want to pursue in the future as well. So there can be some overlap there.
Yeah, so it's part of our research and development, looking at how durable buildings are and looking at the impacts, is that we'd instrument buildings with sensors. And that's where Nicholas is going to come in handy.
Yeah, that would definitely tie in with, just standard setup of data acquisition systems and sensors and analysis. So.
Yeah, I mean, there's quite a bit of science that is involved in this. No pun intended. On your site, you identify simulation software and design software that helps out in the process of developing your plans, right? So, and maybe that's a good shift to kind of talking a little bit about Siemens. What drew you to Siemens?
So Siemens is something I've been involved with for, I think, 2010, 2009, and it dates back to that research project I talked about. We wanted to do 3D thermal modeling, and at that time we were using the free software provided by Lawrence Berkeley Laboratory, which is it was a 2D kind of software called Therm, and just did some research to different kind of software in that, and then somehow got connected with Maya in Montreal, their reseller of Siemens, and we're looking at. First, we bought what they referred to as the Volkswagen because it was a German company. Bought FEMAP, and they talked about the Audi and NX and with now a Sim Center a bit being better, but we didn't really appreciate the difference. But then, as we were going through the project, and there were some people having difficulties with FEMAT, just getting to work for the complexity of the details or the level of detail we're doing. To get the project done, we switched to NX. And then we saw the real benefit of it, of how it saved us time, and we're able to do a lot of different iterations and have that kind of backward capability. So that kind of relationship has just kind of developed over the past decade or whatever, where it's come to a point that I don't necessarily want to use any other software because we're so familiar with it, and we know that there's no limitations to explore different types of problems. So as like Nicholas was talking about, is a lot of the work that we do is multidiscipline. So having the ability to do structural analysis and higher order type of structural analysis, but also add in the flow stuff really helps with looking at the impact of air leakage in buildings and whatnot. And the advanced radiation has been, like past research that we've done has been really handy. We've done that instrumentation of buildings where we're measuring all the temperatures and compared it to the models, and it's been always bang on kind of thing.
The actual modeling that you're doing in simulation and software is actually matching the actual measurements that you're getting out in the field.
Yeah, and that's like a big deal for us a lot of times. When we first did part of that research project I talked about was to do calibration compared between the computer models and what they measure in the lab. At that time, a lot of people didn't trust models. They were skeptical of it, saying that it just was all garbage in, garbage out. That work that we did back then, where we showed how accurate the software was for real building construction, really helped kind of cement the way for all the other work that we did. And then as we added other applications, whether it be the kind of CFD flow analysis or structural, we never stepped in any of those things without doing some field validation kind of thing to make sure that the software was giving us results that we would see in practice.
That's great. That's great. And the relationship with Siemens and Maya has been good?
Yeah, it's been pretty good. I have a funny story that I want to share. The funniest time of it's top of mind, and it fits in with the startup really well, is last year or whatever, when Siemens not the most easiest software to get up and running because of the way that the licensing and whatnot works. So I was stuck on a problem last year where I created a model that I knew was too big, but I thought I could always put it on Amazon Prime and run it on the cloud, use a supercomputer and run it. But through the process of that, it had some difficulties with kind of networking, is being able to pull the licenses off the Amazon computer onto my local computer. The support I got, I was pretty well stuck for a week kind of thing. It was like how to figure this out. I exhausted my knowledge of networking by looking at all the bulletin boards and trying to figure it out, and I just couldn't figure it out. Finally got someone from Maya on a Friday, talked to the guy. He said, well, I'm not a networking guy. I can't figure it out either, but I'm going to put you in touch with someone on Monday. And then on that following Monday, and I had a deadline. I had to finish all the stuff, so there was a little bit of stress related to it. Had a couple of people on the call where it, over an hour or whatever, still wasn't quite figuring it out. And then finally someone came on, said, do this, do this. The guy couldn't explain to me immediately in English what he did, but when he did whatever he said, it ended up working, pulled the license. And I remember saying, I'm so happy right now. And then the guy, my partner at Maya, kind of said, I'm really happy right now too. And I really believed him. So it was just kind of there that you got to know the people over the years and that they're there to help you out. And that I think it's a great thing.
That's great. I appreciate you sharing the story because I think a lot of companies think it seems a big company and small companies don't get listened to very often. But we're changing that, and we're very responsive to everybody, especially startups. The last couple of years, we've been really doing a lot of work with companies like yourselves, just getting off the ground. So, and kind of, I guess that's a good segue. I think people on the listening are here are probably saying, okay, enough is enough. Let's wrap it up. But before we do, maybe you could share a little insights in terms of starting up a company. I like to, hopefully we have lots of young budding entrepreneurs listening to the podcast, and it'd be great to hear from other entrepreneurs in terms of any thoughts or recommendations in terms of getting a company off the ground and running.
Our advice to anyone is start a company with people that you like and trust. When you have that kind of trust, you don't mind being around each other all hours a day. It just makes it easier when you kind of get kind of difficulties and sort through problems and that you know that you're going to always get through it. I'd say focus on your core values and strengths. Don't try to do too much. You're only human. You only can do a certain amount of things. You only have so much time in the day. I believe if you like what you do and you're good at it, then success is bound to follow. And finally, I think always look for partners, especially other smaller companies. I think there's kind of that spirit of everyone kind of help each other out. And if you have some good friends in that, then you can all succeed kind of thing.
Other startup companies have mentioned the same thing, especially the last part around the collaboration, and know what you're good at, do what you're good at, and find good partners to collaborate with in other areas that you need help with. And so it seems to be a good recurring theme of open collaboration, right? And I'm not sure if it's changed much through the years, but it seems that in the past, there's a very competitive nature out there, obviously, but it seems like a lot of young startup companies are very open and looking for collaborators to help them out.
Yeah, it feels that way. That I don't know if it's because of time has changed and people are thinking about it more, or we're being part of a startup. It seems like it's that way or whatever, but it does. It was refreshing. I wasn't necessarily expecting as much support we got from other people that we have.
It seems like your whole company is built around that kind of that team and collaborative spirit anyways. It was really fantastic looking at your website, which, by the way, is Evoke Buildings, EVOKE buildings.com. You can go through there, and it's a very interesting website, and seeing some of the projects that you working on, the types of simulation, the science that goes behind this. I guess to wrap things up, I really, really appreciate you both being here, Patrick and Nicholas. Any parting words or any thoughts for our audience?
No, I don't have a nugget of wisdom saved, unfortunately. No, it's been a pleasure, Paul. Thanks so much for having me.
Well, I guess your nugget of wisdom is, when you're young, you can go out and join younger, smaller companies, right? So follow your passion, right?
Join the best to become the best.
Oh, there you go. I like that. Join the best to become the best. I like that. Very good.
Yeah, I like that too.
Yeah, you like that a little bit too much, Patrick, I think. Join the above average to become the best.
Well, it's
to keep Patrick's ego in check.
It's a really impressive company, and I truly mean it. We've talked to other companies that are in kind of all kinds of industries. This is the first one in this particular field. It was really quite enjoyable to actually kind of look through your website, learn a little bit, go look at the guide. There was a lot there to kind of open my mind up to different types of engineering that was out there. So it was good. I appreciate you guys.
Thank you for the opportunity to do this podcast as well.
As a reminder to everybody out there, thank you for listening today. At Siemens, we do offer special pricing and packaging for young startup companies. You can visit us on www.siemens.com/software for startups, or you can reach out to Maya at mayahtt.com. My name is Paul Musto, and again, thank you for listening to our startup podcast. Please provide any comments that you may have on the episode by leaving a review on your favorite podcast site, or email me directly at paul.musto@siemens.com. And remember, innovation has no boundaries. Thank you, everybody. Bye-bye.